Alright, this is question number 36 on page 719. So they tell us is that they give us these points on these coordinates, and they first want us to find the electric potential, and at the origin here, which I should have marked, I'll mark it right now with a point P. So we know that electric potential is equal to KQ over R, how far away you are from a point. So the first thing I did here was to figure out how far this one here, we know how much it is away from P, 2.533 meters. However, this one, you gotta use some basic trigonometry, which is, you can make it a triangle if you wanted. Which I'm gonna use a different color, so you don't be confused here. So we're gonna make this a triangle, and this is 3.055. It's 4.501. This is a right triangle, so Pythagorean theorem. So you can say, hey, 3.055 squared plus, we'll call this R1 squared, plus 4.501 squared equals R1 squared. So what's R1? So 29.592 equals R1 squared, so R1 has to be 5.44. Okay, nice. Now, it's simple as adding these up. So, we'll call this one, we'll call this one here Q1, and this one here Q2. And so, electric potential has to equal KQ1 over R1 plus KQ2 over R2. So electric potential is equal to 8.99 times 10 to the 9 times 1.8 times 10 to the negative 6 over 5.44 squared plus negative 2. Let's start with K and make it life easier. 8.99 times 10 to the 9 times negative 2.205 times 10 to the negative 6 over 2.533 squared, and I'm gonna just jump to another layer here to make it easier. So if you add those two, you get that up, add those up, you end up getting that the electric potential, the electric potential is equal to 2.74 times 10 to the third volts are 2.74 kilovolts. Simple enough. That was the easiest part. The next part was it asks the one point on the line connecting these two charges where the potential is 0. Find this point. So what they're saying here, they're saying that hey, there's a line which will make four both connecting 2 points. Somewhere along this line, the potential is 0. Well, how do we find that? Well, my first guess would to be use the distance formula, which I'll put some of my notes here. Here it is. Okay. So we know that the distance formula is equal to, between 2 points is x2 minus x1 squared plus y2 minus y1 squared, which you get d is equal to the square root of 3.055 minus negative minus a negative 2.533 squared plus y2 is y1 is just 0, so we just make this one 4.54. I believe the point was 0.501. Okay. 0.1 squared. So we get the distance to equal to 7.175. Yeah, 7.175. Alright, so what can we do with this? Well, what we do with this is that we can set the potential to equal to 0. So the 0 has to equal kq. I'm going to make plus off of x. So d minus x plus kq2 over x. We see that using basic well, just if you solve for that, you get q1x equals negative q2 of d minus x. The k's cancel, so x equal to q2 times d over q2 minus q1 is equal to 1.8 times 10 to the negative 6 times the distance, which we said was 7.175 over 1.8 times 10 to the minus 6 minus a negative 2.205 times 10 to the negative 6. So you should get 3.325 meters. Alright. So solve for x equals x over d times x1 minus x2 plus x2, which is equal to 3.125. Well, 125. Oh, you know what? Yeah, 3.325. Right. All this is at 225. 2.225. Okay, my handwriting my notes here. Over 7.175 times 3.055 minus 2.533. Wow, my handwriting's off here. Which is equal to, your math equal to, negative 0.021 meters. Okay, that's a B. And then for the Y, you just gotta do pretty much the same thing. Just, B times Y1 minus Y2 plus Y2. Just use the same thing. 3.225 over 7.175 meters times 4.501 minus 0 plus 0. So you should get 2.023 meters. So we know the point where electrical potential is 0 is at negative 0.21 comma 2.023, and there we have it, and that's it. So